Okay, so here we go. We got my favorite website in the world, the national, maybe one of the top three. The CDIP also has really good buoy data too, but we'll talk about that later. Anyway, National Data Buoy Center. All these little specks here, if you hover around them, these are buoys. These are all buoys, these yellow triangles, squares, diamonds, whatever you want to call them. These are all buoys that the National Ocean and Atmospheric Administration run. Now you'll see when you hover over them, there's a station number. In this case, it's 44078. That's the station ID, but it also has a name, okay? So let's go over here. Station 41040, that's known as the North Equatorial 1 buoy, and it's about 470 nautical miles east of Martinique. What about here? Well, that's the station SNDP5. It's Sand Island, Midway Islands, blah, 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 blah. Okay, we want to look at some buoys in the Caribbean. So I'm going to zoom in here. Pan over. And we got some cool things going on here. First of all, they always show you where a major storm is, right? This is Melissa, major hurricane. I'm sure everyone's been following this. We got some buoys along the way. I'm very curious to know how the storm has impacted the data, the observations in this buoy. Okay, so this is the 42057 buoy, the Western Caribbean, 195 nautical miles west-southwest of Negril, Jamaica. Okay, so our lab is going to focus on this buoy. But for this, let's just go ahead and look at this one, right, for this tutorial. Okay, we're going to look at this one, 42058. Your lab is in this one, okay? I'm going to click on this. It gives me some information here, and I'm going to go down to View Details. Well, it shows you the location, the date, when you just clicked on it, the current wind observation, current pressure, current air temperature, dew point, water temperature. It's all in Fahrenheit and inches because it's a U.S. monitored, observed, operated station. Okay, we go on and View Details. Boom. So now we got the page. You'll see up here is your station number. The page for this specific buoy. Okay, all this stuff. Here's some data about the buoy. Air temperature is measured 3.7 meters above the elevation. Wind is measured 4.1, blah, blah, blah. Water depth, it's 4.1 kilometers deep. Sounds deep to me. Okay, what the radius of the buoy can move from its mooring along the surface. It can move in a 4,000-yard radius. Okay, so it's not just straight up and down. Okay, here's what it looks like. Oh, here are the pictures of what it looks like right now. I'm going to click on this. It should be dark and stormy. I think that's the name of an alcohol. I think there's a beverage called Dark and Stormy. I don't remember. Okay. Anyway, what do we got here? These are current measurements of all these different parameters. You can click on any one of these. Let's click on wind speed. Right now, it's 19.4 knots, but let's look at the past few days. You can see it's gone up to 30, you know. Now remember, Melissa didn't really strengthen that much before it hit this buoy, right? So you're not going to see that much of an impact, I wouldn't expect. Heat index, okay, warm, day, night, day, night, day, night, day, night. So you're seeing there, right? Okay, now these are meteorological things. Now, what I'm really interested in, or you can see a longer time, you can actually, here you can click on the, you can click on it and see a plot, blah, 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 right there. Or you can go down and see the data itself that made that plot. So we clicked on wind speed, 19.4. Okay, wind speed. And there we go, wind speed, right? All right, so there's the data. And look, current, most recent, the top, goes down all the way from the 28th down to the 27th at 11:50 a.m. to the 28th at about 11:50. So 24 hours, right? And you can see it takes a measurement every 10 minutes. So every 10 minutes there's an observation, okay? Wind direction, wind speed, wind gust, wave height, wave period, average wave period, mean wave direction, pressure tendency, is it getting higher or lower, atmospheric temperature, water temperature, dew point, all kinds of cool information. Now we go down here and you have the wave summary. Now we have parameters like significant wave height, swell period, swell direction, wind wave height, blah, 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 blah. Now, significant wave height, that's the average of the top 1/3 of the measured waves, okay? Clicking on that, whoa, yes, it was about 7 feet a couple of days ago. Melissa came by, boom, waves jacked up to 12 feet, significant wave height. Now you got swell height and wind wave height. Swell height basically means these are generated more from a remote disturbance or longer periods, longer wavelengths. Wind wave height, these are more in the shorter periods, but these are kind of like waves that are being generated by the local winds, right? So look at the swell height. Oh, weird. I don't trust this. Why a bunch of zeros? Something's wrong with this with swell height. I'm not trusting that. Sometimes that happens, right? But you look at the wind wave height. There we go. So most of all the wave height is related to wind, not swell, because the storm is right in the backyard. One would expect that. Again, these are details. I don't expect you to know all this stuff. Just throwing it out there in case you're interested. And like the atmospheric stuff, you have time series data. Now this is every 30 minutes. See this? Wave information is taken every 30 minutes. Wave height, swell period, swell direction, wind wave height, wind wave period, wind wave direction. Is it a steepness, and the average period in terms of seconds, okay? Now I'm going to show you this one just because it's my favorite. This is advanced. I'm going to click on this. This tells you, the spike tells you where most of the energy is coming from. Here's energy, this unit here. No energy to the maximum energy being observed. And these are seconds, these are wave periods, okay? So again, a little advanced for this class, but all the energy is coming in the 8 to 9 second period band, which is considered kind of wind wave. All the swell height, swell period, pretty low energy. So all this big spike of wave energy is coming from basically wind swell being locally generated. Okay, again, favorite plot I like to look at, but don't stress over it. Now what I want you to do is I want to make these plots right here, but not just for the past day. Okay, not for the past day, but for the past many days. So down here, there's an option called real-time data. You can click on this and have data that goes back to 45 days. So what I want you to do, I want you to access real-time data, make a time series plot of a few parameters, not just for a couple days, but for 45 days. All right, so let's dig into that. And remember, this is all specific to this buoy right here, 42058, okay? Let's go down, let's proceed. Let's go down to real-time data. We got options, okay? For this, we want real-time standard meteorological data for the past 45 days. This is a data gold mine, okay? All right, so what do we got here? Click on this. Ah! Numbers. Okay. We got columns here. The year, the month, the date, the hour, the minute. This is all, and you can see every 10 minutes there's an observation point. We'll get to that, missing. So not everything is measured every 10 minutes. Okay, we got wind direction, WDR, wind speed, and look, the line below, the row below gives the units. Wind direction, degrees. Wind speed, meters per second. Gust, meters per second. Wave height in meters. Period in seconds. Average wave period, seconds. Mean wave direction in degrees. These are degrees. 187 degrees, that's just, that's basically due south, right? North is 0, south is 180, east is 90, west is 270, okay? Atmospheric pressure in hectopascals, all right? This is pressure. Atmospheric temperature in degrees Celsius, okay? Water temperature, degrees Celsius. Dew point, degrees Celsius. Visibility, don't worry about that. Pressure tendency, don't worry about that. Tide, don't worry about that. Now, how in the world am I going to make a time series plot of just this column, just wave height? Well, what you got to do, you got to select it. Whoa, tricky with the mouse. Select all. Why does it always do that? Select all. Why does it always? My finger slips. I got fat fingers apparently. Let me try this again. I'm going to take my mouse, click and select, highlight. There we go. Scroll all the way down. I'm highlighting all the way down by clicking and holding and boom. Now, copy. Boom. I've copied all this. And now what I want to do is paste it into an Excel spreadsheet. Okay? So, I'm going to open up a blank Excel spreadsheet. Okay? But before I do that, I skipped a spot. How am I going to just bring all this to Excel? Well, watch. If I copy it and paste it in Excel, it's going to give it all in one cell. It's going to be nasty. Paste. No, not working. That's not what we want to do. Okay, now what we want to do, here's the only tricky part of the lab. We want to paste. Let's see here. Where's a new text file? New. So I've got a new blank text file. I'm going to paste everything in a new text file. Look at that. That looks cool. Okay. So that is pasting all that stuff I copied online these past 45 days into a text file. Now we can easily read in a text file to Excel. So I'm going to save this file. Where's it? Save. And I'm just going to call this Buoy data example. And I'm going to save it in my desktop. Boom. All right. Good. I'm going to close this now. I've got it saved, named. Now in Excel, you're going to read in a text file. Based on the Excel version you're working with, there are different ways to do this, but let's see if it's the way I always do it. Insert. Doesn't work, sorry. Data. There we go. Data. Get data. What happens if I do insert? Can I insert stuff? Nah. You want data, because we're bringing in data. You want the data column. I'm going to go over here. From text. Data from text. It's exactly what we're doing. I'm going to find it. I've got a Buoy example somewhere in here. There it is. Boom. Get data. Boom. All right. Now, I want it delimited, which basically means I want all the data in there separated. So click delimited. Very important. You must click delimited. Next. Well, how do we want to delimit this? By space? Yes. What happens to tab? No, space. I'm delimiting it with space. That means every parameter and measurement has its own cell. All right. Next. General, sure, why not? Keep it all the same, blah, blah, blah. Finish. Import right there. Yeah, let's do it. Import. Boom. Great. This is what I want. All this stuff I don't need. It's just kind of a distraction. And don't worry about it if you don't want to do this. I'm just going to get this out of here. I'm going to delete that. Cool. Now, here's the deal. These look good. What do we got? Stroke width, don't matter what that is. Okay, now here's the deal, right? I'm going to delete these two. Watch what happens. Shift cells left. Here's why I'm deleting it. Here's the year. But here, the year is in column C. I want it to be column A. The month is in column D, but I want it to be in column B. If I delete these two useless cells right here, shift the cells left, boom. Now everything lines up. Years, yes. Months, yes. Days, yes. Hours, yes. Minutes, yes. Everything, wind speed, yes. Wave height, meters, yes. Okay. So now in Excel, I have everything I need. Okay. So if I want to do a time series plot of wave height, all I got to do is select this entire column of numbers. So I'm going to click here, Shift, Command, and the down, or you can just drag and drop. And I've selected all of these. Now there's going to be a little bit of a problem, but I'll show you what. So here, I'm going to insert a line plot. See that? 2D line. Boom. Ah, I did not get what I was expecting. Dang it. I know why. Okay. Let's get rid of this. Delete. If you start your plot with that means missing, it goes haywire. So you want to start it on the first number. So 3 meters here, right? You can have following. Now look. Basically, this is telling you that you don't have wave height measurements every 10 minutes. You got pressure almost every 10 minutes. Basically every 10 minutes. Here's one you have a missing for whatever reason. But let's just do this. I'm going to click here. I'm going to select everything below that. And I'm going to get a time series plot of wave height in meters. Again, insert these little 2D line. Boom. There we go. There's my answer. Now, one thing to be aware of, the most recent time is on the far left. So here you can see, yeah, look at this. We had 4 meters. This is when probably a tropical storm was heading by that buoy. Remember, this buoy is east of Jamaica. So yeah, we got 4 meter waves, and now we're still up to 3.5 meter waves. Now before that, you got maybe 2, maybe 1. Here, you got 2. So the wave height is essentially double in terms of meters. So we're talking about, 12 feet or so, when before it's usually about 3 feet. Some things came up here 45 days ago, some kind of tropical storm, wind event or something, and the waves actually jumped up to about 2.5 meters. So anyway, this is the answer to one of the labs. All right, so here we go. Whoop, sorry. 3 plots from part 6. What are we plotting? In the past 45 days, we want sea surface temperature, wave height, I just did wave height, and wind speed as a line plot. Okay, let's look at what if I can click on this? Chart title? Yeah, why not just name this wave height. Boom. There we go. Now I won't be confused. That's wave height. Now I want to do water temperature, which is right here, WTMP, degrees Celsius. I'm going to select all of these. I'm going to insert another plot right there. Ooh, look at this. Now why? Maybe it looks like there was some missing data somewhere or something. Let's see if I can go up here and see what the deal is. Oh, there we go. MMM missing, right? So here's what I'm going to do. I don't like the way this looks because the water temperature is roughly 28 to 31 degrees, but it goes down to 0. I don't want 0 to 31. I want about 28 to 31. I'll show you why, right? Now I think I can right click this. Format axis. Yeah. Boom. I don't want to go from 0 to 35. Let's try 28 to 31.5. Oh, that looks a lot better. Actually, let's go to 29. Let's go to 29. There we go. I see some cool things here. Day, night, day, night, day, night, day, night. So diurnal cycle. Yeah, it warms up with the sunshine. Day, night, day, night, day, night. I don't know what happened here. Got much warmer in that part of the day. Maybe there's 0 clouds or something. But this is the most recent. Look at this. What's going on with the sea surface temperature as Melissa approached and passed by? Remember, this is the most recent. Huh. Did Melissa have anything to do with decreasing the sea surface temperature? Well, think about cloud cover. Think about evaporative cooling with winds. Yeah, look at that. You see a clear impact. So, with Melissa, let's change this here. I'm going to name it sea surface temperature. There we go. So I should have 2 plots now. I don't know where my... There it is. There's my wave height. Now you might be asking, how am I going to get this? Do a screen capture. Maybe you can copy this and paste it somewhere. Take a picture of it. Just show me, right? I'm not going to make you format the x-axis labels. Just know what the y-axis means. Wave heights in meters. Sea surface temperatures in degrees Celsius, okay? But we're looking at relationships here. Cooler with Melissa. Bigger waves with Melissa. And the final thing was wind speed. Okay, meters per second. I'm going to do the exact same thing. Select all of these. Insert. Line plot. Boom. Ooh. Look at this. These are meters per second, right? So, someone's calling, you have to wait. Wait. Yeah. So wind speed. Look at the impact. Look at the prolonged high wind speed, 12 meters per second. I believe that's roughly 12 times 3 miles per hour. Let's see here. 12 meters per second to miles an hour. About 27 miles an hour. All right. 27 miles an hour. So there we go. We got wind speed now. So look, we have the relationship between wind speed, wave height, and sea surface temperature. Okay? This is all I want you to do. Have these 3 plots. What's the highest wave height? When was it? I'm going to ask you, when was it? Now, how do you find it? What is the highest wave height? Well, go back to your data. You know? When was this for? Oh, look at that. 0.848. About 0.848. So I'm going to go down here. Look for row 848. And that was October 22nd at 1750 Z time. Okay, well, there you go. That's how I found it. I know exactly when this was. Okay, roughly. All right. Questions? Yep. When was that? How might Hurricane Melissa have influenced the observations? Right. One sentence per parameter. How did? What do you think Melissa did to cause the wind speed to do that, the sea surface temperature to do what you saw, and the wave height to do what you saw? Okay. Now, these are not rocket science questions, right? The point is not to test your expertise on the physics of climate and marine meteorology. The whole point of this is to bring your awareness to where is it? This website. I want you to know that there's a place online, the National Data Buoy Center, that has all these buoys you can explore. Okay? Know that. That is what's going to make me happy. If someone comes up to you and asks you about ocean information, say, oh, I can look at the National Data Buoy Center, pick out my buoy. I know where to get last 5 days observations. I can look at a plot and look at the numbers. I also know how to get the past 45 days. I can do some analysis with it, okay? Play around with it. You'll have fun. Any questions? Let me know. I hope this has been helpful. I'm very, very sorry I wasn't able to make it today. I had a feeling my motorcycle was left idle for way too long and the battery needs to be replaced. So I'm charging it now. Questions, let me know. Hope you enjoy this as much as I do.